Hi, welcome to the session. Sorry, this screen is right here, so I'm going to actually walk around so I'm not alienating anybody from the audience. Welcome to the session on real-time big data analytics. We're going to talk about what are we doing in Azure to help solve problems on getting insights now. I'm going to be joined on stage by one of our customers, Greg Floyd, from Southern Company, and Greg will give an example of how his company is being fundamentally impacted by what we are doing on Azure with real-time analytics. Thank you, Greg. So, I'm Santosh Balasubramanian. I run the product or program management team for stream analytics, time series analytics, and some of the big data workloads here in Azure. A lot of what we do is also related to IoT analytics. So, if folks went to the IoT general session, you might have seen me there today, or even the previous IoT analytics talks, there'll be certain things that we'll talk about again. Let me get started. We have a packed agenda. We're going to talk about streaming, and I actually want to talk about the history of streaming, and even though this session is on Azure Stream Analytics, I'm going to talk about what else on Azure we do in order to help you with your streaming needs, right? In the end of the day, we want to make sure you as an Azure customer, we meet you where you are. I'm going to request, then I'm going to get into some of the details of Azure Stream Analytics before Greg joins me up on stage and talks a little bit about how his company uses us. We're going to talk about some of the new exciting things for people who have used Stream Analytics, but we are adding a bunch of things with AI, things like machine learning models, like anomaly detection, which is actually built into the Azure Stream Analytics product. Azure Functions, how you can call out to call arbitrary HTTP endpoints or send emails from alerts and other things which can be done very easily. User-defined, so as you know, we allow custom code in JavaScript, but how can we extend it to actually do temporal functions with your own custom code in JavaScript? User-defined UDAs, user-defined aggregates. How we are actually now going more and more enterprise-ready with our Visual Studio tooling, sync with VSTS, with continuous integration and deployment, which can be done now with Stream Analytics and everything else that other services that you want to actually do continuous deployment for. And I will also talk about some of the futures in Edge Analytics in the session. So we have a full session. One of the things that I request is I try to take questions only at certain points so it doesn't impact the flow of other people. If you have any questions, please feel free to email NRTPM team. This is at Microsoft.com. I will actually put the alias out also in certain slides, or you can tweet to @Azure Streaming. This is also part of our team, where you will PMs on the team are actually looking at what are the things that you tweet. Okay, so why are we here? Like, why is real-time analytics interesting? You know, one of the first things I got into the space also, like relatively recently. I've been in Microsoft, MSR, SQL Server, Power BI, Search, and then I really went into the space, I want to say 2.5, 3 years back. First thing somebody told me, you know what? There are certain things that if you don't get the insights on time, it is completely useless. Like just forget about it, store the data and do something else, or even lose the data. That's one of the most important things. Time to insight is critical for our business. I'm curious, I just had an IoT analytics session before this one. Folks who went to that? Okay, thankfully lesser folks, but then the content that I'm going to share some content which I shared there, so it'll be new as well. So time to insights is not just when I'm running a pump and suddenly the pressure in the pump has decreased and I want to shut it down. That's very important. But think about it in scenarios such as I am doing digital marketing and I am looking at Twitter and other social media feeds and figuring out that suddenly the negative sentiment on something that I've just put to market has increased. Time to insights for that, for your marketing team, is very critical. We have customers who are running things such as their whole server monitoring workloads, where if their web servers are down and a percentage of web servers are down, then they have issues with the SLAs that they give to their customers. So time to insights are important there. Greg will talk about how time to insights are essential in the Southern Company and what they are doing for their customers as well. And the last thing is The fundamental difference between data at motion and data at rest is you're asking questions from the data when the data is still flowing. So the best way I say this is, I'm going to give an example of batch and streaming with a completely different example. Let us say we are in a parking lot, and there are cars in the parking lot, and I'm asking a simple question. Tell me how many red cars are there in this parking lot. All the cars are parked. I can ask that question, select count star from parking lot where car color equals red. Great. Ask the question, get an answer back. 5 minutes later, I can ask the same question, get the answer back. The query dies. Imagine if we ask this in a slightly different way. I'm on a highway. I'm at a point on a highway. Cars are zipping through. And I ask the question, every 5 minutes, how many red cars have passed this point? That is streaming. The cars are data in motion. Every 5 minutes, this query never dies. It computes for 5 minutes, gives a result. Keeps computing for the next 5 minutes, gives a result. Windows in which results are given. This is data in motion. And that's what we mean by we are querying data, the query never dies, it's actually in motion that we are doing it. The canonical scenarios that I have heard from customers while thinking about these scenarios are, number one, let's take the example of this building, right? If I am the person or the company which is doing monitoring of the comfort level of people in this room, in this building, then, at this conference center, I want to be able to see a live dashboard. I want to see what is the live status of my millions of sensors which are sending data into the building. I want to do some aggregations. I want to do some analysis on top of it before I see that. I don't want to see every sensor. I might want to see 3 lines. Conference center 1, what is the average temperature? Conference center 2, conference center 3. But what is happening? Millions of sensor readings. I'm running some analytics on top of it, and I'm getting one result out into my BI dashboard. I'm actually going to show you an example of that today. I want to be able to detect anomalies. And anomalies is a very overloaded term, and I'm going to try to go to both aspects of that overloaded term. Anomaly is, I know that an issue is occurring if the temperature goes over 90 degrees, and I want to create a ticket. I want to kick off a workflow, right? Another thing is, I want the system to learn on what was happening and automatically detect when things change. Anomaly detection models, machine learning, intelligence which is put into my pipeline. I'm going to show you both of those. But it's not about detecting, it is also about the workflows that I can kick off. So I want to send emails, I want to create, actually our customers are creating ServiceNow tickets, for example, right? Because that's what they use for their alerting and monitoring. The third thing is, I want to be able to also control machines. So not only do I want to take a workflow as a human action, I also want to be able to trigger an action on a machine when something like this, when I detect an anomaly. And the next thing is, I want to be able to augment my data in motion with data at rest. I don't know how many of you guys have seen this, but I'm noticing this more and more. People are thinking about, you know what, bandwidth can get expensive the more and more data I push. So how do I start thinking about decreasing the payload while taking reference data, what we call it, which is data at rest, which I can augment with my streaming data in the cloud before I do analytics. So I can just send ID and value, which means nothing unless you say the ID is associated to this company, to this factory, to this device, to this manufacturer. You don't have to send the whole payload. You can just send the ID and value with changes. Everything else can be augmented in the cloud. So that's reference data. Why I'm doing that? Because now I'm enriching the data before I store it, and I can do other analytics on top of it. So these are some canonical scenarios that we see. Stream analytics is what I'm talking about today, is used in a variety of different fields. Everything from Azure Security Service uses us for some fraud detection scenarios, which is an internal scenario, to we have folks using us for call center analysis. We are going to talk about energy grid scenarios and IoT scenarios today. Fleet management scenarios, really one of the differentiating things that we have brought into the industry. And so let me actually talk about the customers. Actually, before I talk about the customers, I talked about the various scenarios like connected cars that streaming analytics is used for. Let me talk about why Microsoft is well placed to help your needs with streaming analytics. Microsoft started working on streaming actually back when I was in MSR, actually even before I joined MSR in 2006. We actually released some papers on an engine, stream processing engine called Trill. Trill is one of actually industry's fastest. It's based on Cedar algebra. It creates columnar stores. It actually does stream processing internally. And what it gives you is the ability to do temporal processing, fundamental temporal processing. What we did as an external product from this research which happened in MSR is Stream Insight. I am curious, anybody here has heard or used Stream Insight? One. Anybody else? All right, we need to work on that. That's a part of my team too. But that actually ships with SQL Server. And Stream Insight is something which ships with SQL Server. There are customers that I work with who are using Stream Insight also in fraud detection scenarios. Actually, in oil and gas, it's used quite a lot. There's some papers which have been written on that as well. But then we came up and said, you know what? We need to look at what is this next generation of applications which are going to be born on the cloud. What is the next generation of analytics which will be done on the cloud? And really start thinking about using the value of the cloud with the scale-out technologies, with the simplicity of the cloud, multi-tenancy, all of these core values of the cloud. And we built Azure Stream Analytics. We actually took components of Trill and we made it we put it on a multi-tenant architecture. We made it scale out where you don't have to think about scaling. I'll talk a little more about it. And then we actually went and said, it is not only about the things that we built, it is also, there is an open source ecosystem with Storm, with Spark streaming, with Kafka. How do we embrace your needs in that as well? So we released, HD Insight has released HD Insight Storm, HD Insight Spark streaming. They're doing Kafka right now, which I believe is in preview. And then, I'm just going through this journey, which I'll actually say something which I'm excited about the most right now because this is something that I've been passionate about. We not only thought about with Stream Analytics doing streaming in the cloud, but learning about low latency scenarios, disconnected scenarios, and things like that, how we can take some of that power of the cloud and run it on devices. So this is the extent of streaming that Microsoft is into. And before I go into Azure Stream Analytics, I really want to spend a couple of seconds just looking at some of our HD Insight. When I say HDI, I mean HD Insight. These are our open source offerings in the cloud. HD Insight has Kafka, it has Storm, it has Spark. We have customers like Toyota, which is actually doing certain use cases on this, which uses, I believe, both IoT Hub and Storm or Spark in order to do this. We recently actually, HD Insight has a lot of customers. They just bought Kafka as well into the public preview, and they're going to take this to GA at some point. I apologize, I don't have all the details. If you have any questions with regard to HD Insight, please send me an email. You will see actually my email alias a little later, and I'll connect you with the right people. But the real reason I'm bringing this slide out is I really want you guys to not just think that what we are talking about today is the only option Microsoft has. We want to play with the whole ecosystem. All right, let's go into Azure Stream Analytics, something I love personally. So what is Azure Stream Analytics? It's a fully managed stream processing solution, multi-tenant solution. It allows you to write your code in a very simple SQL-like language. Actually, it's funny, I was walking with one of the individuals in the last, from my previous session, which ended at 3:30 to here, and they said, when Stream Analytics came out, in the first hour, I was able to set up my first end-to-end solution. Why? We have put a very simple SQL-like language on top of this. And the SQL-like language has been extended to give you some temporal functions. So things such as, I want to be able to, remember I said, I want to know every 5 minutes what red cars go. We have given you windowing functions like tumbling windows, hopping windows, sliding windows, which actually enable you to do that. I'm actually curious, people who have used Stream Analytics here? Okay, there's only a few, so I will go into the basics first before I go into the next level of details as well. It is a fully managed service. It is a serverless service. You do not have to think about provisioning anything. Even though it is a fully scaled out solution, what I mean by that is You don't have to think about the nodes it's running in. You just ask for compute in terms of what we call streaming units. And you can write your queries fully partitioned, which we automatically figure out for you logically which node does it have to run on. So we help you scale out to gigabytes per second if you have to go at some point. Ease of getting started is very important. We have built a lot of connectors to ingress data like IoT Hub and Event Hub, and in the next slide you will also see to egress data. We also have all the SLAs, 3 nines of availability. We've done a lot of work, and we keep working on improving things such as how do you do the debuggability for the service, and other things is it's a pay-as-you-go service. You literally can walk out of here, and for 11 cents an hour, you can set up your first streaming pipeline with everything and more that I'm going to show you today. So, thousands of customers, everyone from, we have certain soccer, there are people who are using us for things like social media analysis, to Honeywell, I'll talk about them. They are using us for a connected building solution. We'll talk about how Southern Company is using us as well. Honeywell is literally using us for the scenario which I started with. It sells comfort as a service. So how can you monitor, do remote monitoring of all the sensors in a room and do things such as, in a room if there is more heat than other areas, what is that area? How do I kick off a workflow immediately? How does my building look right now? All of these things are being done on the streaming pipeline. This is actually fun. NASCAR, we just did geospatial analytics, and NASCAR was actually our first customer. Interestingly, what they use us for is during an accident, generally they use video evidence to see what's the distance between cars. So they started looking at how can we actually reduce the time for that by collecting distance between objects. So automatically we can actually say things such as what is the distance between cars and reduce the time from video evidence to actual sensor evidence in order to do it. TransAlta, they're actually going to join also the Time Series Insight session tomorrow. I believe they're Canada's #1 wind turbine company, and how they are using us to do things such as remote monitoring and predictive maintenance and other aspects as well. All of these case studies are actually available on Azure Customer Success Stories. So what is the Stream Analytics pipeline? The pipeline is something which basically is you have real-time data sources such as event hubs and IoT hubs from where I can ingress data. So, and we also allow you to push data to blobs and automatically read data when blobs are there, triggered from when the write of the blobs happen. We have reference data. This is the data at rest which you augment with data at motion that you can do in Stream Analytics. We allow you to call machine learning models for scoring from within your logic of Stream Analytics, that SQL-like logic. And there are other things that I'll talk about today as well. And then let's talk about the stores or the sinks. So I talked about real-time dashboarding as one of the things. Real-time Power BI, you'll see some demos here. You can write to stores such as Cosmos DB, Azure Data Lake, Blobs, SQL Data Warehouse, and a variety of other stores after you augment or do something with your streaming data. You can also kick off workflows such as sending emails, which I will try to show you today, or creating tickets in ServiceNow, or running your own workflows using services like Service Bus Topics, Queues, Azure Functions, and Event Hubs. Azure Functions is something we just went in preview with. It's a part of the Azure IoT suite, as you can guess. It's real-time analytics is very core to IoT analytics. It is also a part of the Cortana Intelligence suite, because this is that real-time analytics component which intermingled with machine learning, batch analytics, storage, and other things which is there in Microsoft Azure. So what I had told you, one of the big things that we worked on in Azure Stream Analytics is really decreasing the bar of developer, the challenges which are there for developers. So imagine writing a query which says, I want to be able to bring in data from one gateway, let's say, which is connected to this building. I want to join it with weather data, and then I want to do some computations on top of that over a temporal window to see, the anomaly is not just because the temperature here is increasing, but the outside temperature is also a particular temperature. Seems a simple thing to write, but imagine writing this in Java. Imagine writing this in LINQ. You can write this literally in 7 lines of code in stream analytics. If you know SQL, you can write your stream processing query. I can do things such as selects, group bys, joins. I can join two streams of data literally like I do in SQL with inner join, or left outer join, events coming from one thing but not coming from another thing. Think about people familiar with SQL. I'm just curious. Okay, nearly all of you guys can go and do this. Like, I want to detect the absence of events. Things like this can be done using this SQL-like language. We have added windowing functions, and we will keep adding more windowing functions in order to make your processing much easier. We have things like tumbling windows, which every 5 seconds I want an answer, versus I want an answer for the last 5 seconds, but I want it to come every second. That's something like a hopping window. Or I want an answer when an event comes into a system and leaves the window. So that's a sliding window. Things like this have been built into the system. We have windowing functions like lag, which we will actually show later today. And of course, one of the things I am excited about, because fleet management is picking up quite a bit, is things like geospatial functions that we have added into the system. I talked about windowing concepts a little bit, but let me actually start with the first demo. And actually, before I show you the demo, I just want to tell you what is happening in this demo. I have an event generator. My event generator is sending temperature data between at 57 degrees with a variation of 10 degrees, so between 47 and 67, and it's sending it every 500 milliseconds. It is sending this to IoT Hub. IoT Hub, Event Hub, I'm hoping people here are aware of this. Have you guys heard about IoT Hub and Event Hub here? Anybody who hasn't? People have heard about Kafka here? Okay, so I'll explain what this is a little bit. Whenever you're working with streaming data, you need some kind of a way to ingest this data at scale. So think about this as a service which enables you to send millions of events. It's able to not just capture the millions of events, but also with millisecond latencies, those events can be read by other services like Stream Analytics. It allows you to store the data for a small period of time in case you want to go back in history and read it. So things like Kafka, like Event Hub, like IoT Hub actually help you do this. IoT Hub is specifically built for IoT use cases where you can not just send your data and your telemetry, but you can also send commands back to devices. It enables you with security. It enables you to do things such as device management. So if you're thinking IoT scenarios, do think IoT Hub in a lot of ways, because it's more than just getting in telemetry. But once I send my real-time data through these things, which in this case I'm sending it to an IoT Hub, my goal is very simple. I want to be able to show what is the, apologies, I have the wrong dashboard. I want to show a very simple thing. I want to say, even though the data is coming every 500 milliseconds to IoT Hub, as you can see, I only want to see the results every 5 seconds. So I want to aggregate the data across these millions of these sensors which are sending it, right? So this is where Stream Analytics comes into play. So I can go to Stream Analytics, I can go to the Azure portal, create what is called a Stream Analytics job. My Stream Analytics job has a few things. It has an input, which is the input of the IoT Hub. It has an output. The output is basically the Power BI dashboard, which I have created, or it's a Power BI streaming data set in this case. And I forgot to show you the input. This is just the IoT Hub input. I can have multiple IoT Hubs or Event Hubs or other ways to input data into the system, because I can join them using queries. And then my query is as simple as this. Select device ID, because if you saw that payload was sending device ID, temperature, and things. System.timestamp is the time which the system has when it writes the result every 5 seconds. Average temperature, that's it. You could be sending millions of sensors which are sending temperature, but all you need to write is this average temperature into output. I said the Power BI was that output with the alias that I put as output, from read from my input, grouped by device ID, tumbling window of 5 seconds. So every 5 seconds, my millions of sensors just send that one result out to Power BI dashboard. This is how simple we have actually made stream processing. This seems like a very simple example, but you can assume using something like this, I can do a variety of different tasks, which I'm actually going to show you in the next set of examples. I wanted to show you before I do other things, like what are the ways I can interact with stream analytics. I can do it using the Azure portal, which I just showed. I can do it with PowerShell scripts, .NET SDKs, REST APIs, and we also have Visual Studio tools. We are actually today in this, I'm announcing also integration for continuous integration, continuous deployment with VSTS and other things that we have actually added into the system for developer productivity. Apart from the simple SQL-like language, I can join multiple streams of data together. I can add reference data. I have custom code in JavaScript. Until now, we did JavaScript user-defined functions. Now we allow you to actually do user-defined aggregates, which I will talk about a little later. You can call out to machine learning models. As of today, I'm also announcing how you can use anomaly detection model, machine learning models which are built into your stream analytics pipelines, which I will show you in an example. Built-in troubleshooting, debugging, Visual Studio plugin, and the scale-out architecture that I already talked about. Another very important thing which people are like, hey, I'm just going to go and write my temporal aggregation in a, in a virtual machine using some small piece of code. When you're thinking about stream processing, you need to think about a lot of other things. You need to think about what is the timestamp you want to work on. Do you want to work on the timestamp of when the data was generated on the device, or when it was already sent to one of your ingestion services in the cloud, like Event Hub or IoT Hub? What kind of windowing functions do I need? How do I order these events? If everybody here had a sensor like a Fitbit or iWatch or something, and it was sending heart rate, right? And you want to do some processing based on the order of what it was being sent. How do I automatically order those events? Things like this is built like configurations into the system. If I have two different buildings which are sending data through a gateway, how do I manage the latency between those two before I actually reorder the event? Things like this is built into the system. You need to think about checkpointing. If I am doing a 1 hour window and I have a failure in the 59th minute, am I going to read from the 0th minute and reprocess everything? Or is the system have built-in checkpointing which will go back in history when the last checkpoint was written for fastest recovery? Things like this you have to build into the system. And of course, data at rest and data in motion, how you do join things. So again, when you're thinking about stream processing, it's not just about I need that average 5 seconds. You need to start thinking about all of these things that you're building, which we have built into the system as a baseline, including the checkpointing and things. Few complex queries. I can do things such as counting unique values. I can do things such as find the first event in a window, last event in a window. I really like this. This we added recently, filling missing values, because there were customers who were saying, hey, we don't want to send every event. We only want to send events whenever there is a change. But in order to do the processing, I want to be able to see what was the last value so I can fill some missing values. So things like this can be done using our SQL language. One thing which we did, as I was talking about the geospatial functions, I would actually say, I think talking to, doing competitive research, talking to customers, I believe we are one of the first real-time multi-tenant stream processing solution which has given us SQL-like geospatial functions in the system. So now I can find distance between two objects. I can see if an object is within a particular geofence. I can do things such as actually, let me go to the next slide. I did miss the slide, so I'll tell you some of the things before I go. I can do things such as how far are certain cell phones from cell towers. There's a customer who's actually looking at us for that. Fleet management is what we are going to talk about right now. There is a customer who's working on us for a very interesting use case. These days you go and you can go to stores and you can order your food or coffee or like beverages using your cell phone app. Right now what happens is the person who orders first, that is how the order queue is. Imagine you could use real-time geospatial analytics to actually map your order queue in retail. So it is not just in the order of what you have said, but how far you are from the store that your order queue can be changed. So things like this you can actually do in fundamentally changing the way you run your business with fleet management, with geospatial functions. So what I'm going to do is actually I'm going to show you a demo, a quick demo before I call Greg on stage. So what I'm doing in this demo is I am sending two things. One, I am simulating the position of a car, and I'm sending the latitude and the longitude to event hub or an IoT hub in this case. Actually, it's an event hub in this case. And then another thing I'm doing is also, and this is real, I am going to one of the weather services, and I'm pulling what is the current weather data for a particular location. For example, in this particular example, it said it's pulled the location of New Mexico, and it's actually, I stopped it before it was reading the data, but it actually shows the data in kelvins. So once I pull this, I am pushing this data to event hubs, so two different event hubs, and I'm going to show you some of the processing that we are doing on top of this. Number one, I just want to see where are all the different cars that it's sending data in. And if I zoom into this, you will actually see the cars actually moving as well. But I want to show you actually an interesting analytical query. I only want to see the cars which are there in Colorado. So you are still seeing that, I apologize, it is this particular thing. I'm still sending all the different cars' positions. But as soon as I clicked on that particular query, that I only want to see cars within Colorado, I see only one result. So let me show you how I do this. I use my geospatial queries, and now I'm actually going to go to Visual Studio because I'm guessing there will be a set of developers here who will be interested in this. And please don't, okay, there it is. Let me make it a little bigger. I apologize, this is a, I have my two event hubs that the data is coming to. These are all the different queries, and the one query is, tell me when a car is in Colorado. So how am I using my geospatial functions to do this? I'm saying select the location of the car, which is input, which is from here, the GPS locations, into the event hub output, which says only Colorado, show me cars in Colorado, from the event hub, and tell me this only when the location of the car, which is the latitude and longitude of the car, is within the polygon which is created for the state of Colorado. So basically, I can go to a Bing map or a Google map, and I can see what are the locations of the four like rectangles or other places to create a polygon. And I can say ST within, if this GPS location is within this polygon, tell me yes or no, and just send me that result. Imagine writing this in a different language and see how SQL can enable you to do this very easily. So I can add reference data for different states. I can say, I can do a lot of things with such a fleet management like solution. I'll show you another example as well. And this really depends. I think, 300 Kelvin is 70 degrees, right? Sorry, you can see that there's a developer like me who has done this. So let me see, what is 300 Kelvin in Fahrenheit? All right, to Fahrenheit. Let's see what to Fahrenheit. Anybody can guess it? I think it's 80 degrees. It is 80 degrees. Okay. So I'm saying show me cars which is close to 80 degrees. And really, I don't know if this will give a result because I'm pulling real-time data. Or let me see if it show me cars which is close to 293, which I think is 72 degrees. So in US, if there is no location like this, I won't get a result. Why I'm showing you this is actually doing distance, ST distance between the two, a place and every car which is actually flowing through the system. So, actually there is. So Wyoming, in Wyoming it is close to 70 degrees right now. And I'll actually show you this query just because we got a result here. So this is close to low output. So this query is very similar. Select the cars which is into low output event hub, which is actually displaying on that particular map, from my GPS input, join with my weather input in a 5-minute window. So because there's a temporal join that you're trying to do, where the distance between the latitude and longitude of the car, ST distance, and that point of the weather latitude and longitude is less than, I think, 50,000 kilometers here, and the weather is less than 293. So even though, I mean, this is a complex thing that we're talking about, all the cars, all the states, but you can actually express this so easily. So after I did this, I am actually going to invite Greg on stage. Greg, please. Greg is from the Sun Company. Please give a hand, and I would love for them to walk through how they are helping and using Stream Analytics.
Thank you, Santosh. So I am Greg Floyd. I am Principal Enterprise Architect with Southern Company. And my focus is on emerging technologies in the industry for our enterprise adoption. So Southern Company is a premier energy company. It's composed of natural gas, electric, and other companies. We have 9 million customers, and it's hosted out of the Southeast in Atlanta. So one of the reasons I was asked to come up here and talk is how we used Azure Streaming Analytics. And the reason we did is we chose it to track asset, vehicles, and crews throughout our territories for Georgia Power, one of our utilities in the Southeast. Assets are commercial equipment, so it's going to be construction equipment like backhoes or trailers or even containers. When you open a container, you get an alert. Vehicles are going to be your bucket trucks that are essential for restoring power for a utility. And then crews could be external crews like Irma. When Irma happens, often a lot of the crews will get together and they'll help each other out. How do you track those external crews if they don't have your trackers in their trucks? So tracking asset, vehicle, and crews were essential to helping us with storm restoration. Everybody knows what happened with Irma. We had to track bucket trucks. We have to get the right skills, the right people, the right equipment at the right places, and do the job quickly. It took us a good amount of time to get Georgia restored, and as you know, Florida as well. So theft prevention. If you've got a tracker on equipment and the equipment walks off the job site, it's easier to find. One of those pieces of equipment could be a portable substation, hundreds of thousands of dollars. Safe driving. If you've got trackers on your vehicle, you can do some common calculations to figure out the speed, the aggressive driving tactics, and things like that. And we want to promote safe driving. And then lone worker protection. These are some of the use cases that we built around streaming analytics. I'm going to focus on the asset and vehicle location. So here's our solution architecture. And as you'll notice, it's a brokered architecture. And we're actually receiving events from two types of trackers. One is a basic tracker that is provided and provisioned by vendors. And so we have various vendors out there that provide us fleet management for our distribution or fleet or other companies. And what we want to do with those basic trackers is bring those in and forward them to our vendors so that, as usual, they can promote their software, which they're best at. And then we transform that message into our IoT hub. Then we have advanced devices, and the advanced devices are going to be like your cell phone. So we can write an app that tracks your location. You can turn it on when you're on the clock, and it can ping your location. It could also be a crew advanced workstation device. So all this data flows into the IoT hub and then into streaming analytics. And streaming analytics is where we take all this data and we canonicalize it into that IoT hub into a single message structure. And so we can report across any device, across any vehicle or crew in the same manner. And so the streaming analytics will allow us to take that data and reduce it to a manageable data set that we output into an event hub and then it comes back onto premise into our back office systems. So what you see here is an example of a vendor telematics fleet management system where we're tracking a single truck throughout the day through his workday. This was actually brought in through the basic tracker. It was received in the cloud, forwarded to the vendor. That same message went into our IoT hub and then through our streaming analytics and brought back down onto premise through our outage management system.
Craig, do you want to show some of the queries?
Sure.
Make it. I can bring up the Visual Studio.
So while he's doing that, streaming analytics saved us a lot of time. Instead of writing functions that would have to calculate, when was the last time we heard from this vehicle, which of these devices have we not heard from? Is this device or a piece of equipment out of range? Streaming analytics allowed us to use some built-in functions and UDFs that we could use to quickly, using SQL, insert this data into to our event hub that we then received on-site and published into our infrastructure.
I do apologize. For some reason, with the resolution, my Visual Studio is not showing.
Oh, there you go.
Can we just do it this way, if you don't mind?
Sure, sure. Okay.
Oh, yeah, I think you'll have to. Yeah. It's the other Visual Studio. I apologize. Yeah. Now, let me just close this as well. We might not be able to go over the full query because I was having a resolution problem. Do you just want to talk a little bit about whatever is on the screen?
Sure. So what we did is we used different stages. And what you see is the first stage, actually, where we go and look at the previous time we heard from a device or a piece of equipment. We get that, and then we partition it over the device ID, and then we insert it into the second step.
I'm going to kill this. Do you want to keep talking about what it is while I try to get it back on?
Sure, sure. So what this did for us is if we had to write this, we would have to track the last time we heard from a message, keep a repository. As it was, we leveraged the IoT hub and the ability to look back 4 hours and compare the current position to the previous position. We then took that and then we evaluated, okay, from a windowing technique, remember, streaming analytics is about looking at data as it moves across. So we took small time slices. And our business portfolio only wanted to see equipment that moved 1/4 mile over a 2-hour period. And for those, we consider, if it did move 1/4 mile over a 2-hour period, we considered an inactive piece of equipment. And they only wanted to know about the most recent location every 2 hours. For anything that did move beyond that, we wanted to know every 2 minutes. And so streaming analytics allowed us to use a window to do that. And that's what we did with our streaming analytics job.
I'm sorry, we are unable to show the job right now. I'm going to try once again to bring it up.
So while he's doing that, we did, so we basically took the lat long of each message. And remember, each of these devices sends individual messages that could be informational. It could be event-driven. In other words, it's an alert that a door opened. It could be just here's my current location, or it could be a diagnostic warning. So we receive all these messages. We transform it, like I said, into a canonical, stuff it into the IoT hub, and now, regardless of what those vendors have provisioned that device to do, we can treat every device the same, and we can consolidate those regionally. And then as we iterate through those, we pull down the active vehicles every 2 minutes in a 2-minute window, and the inactive vehicles we receive every 2 hours. And then that feeds into our BizTalk infrastructure, which forwards it on into our outage management system.
Sorry, Greg, unfortunately, the query is not opening up in Visual Studio. We
Okay,
should probably
well,
just continue. But I hope you guys got an idea about what Greg is talking about
so,
here.
yeah, some of the functions we used windowing techniques, we used distance functions, we used lag and lead functions, and we were able to compute the distance. We can also compute the acceleration, because if you remember, as external crews, if we're tracking those, they're going to talk directly into the IoT hub. And for those, we can just take the GPS coordinates and track their distance over a period of time, so we can track their speed and what their movement is. One of the things that's key to any solution is to have a dashboard. And so we used App Insights to track the information. One of the key things is, this is a blue sky day that you see with just our pilot devices. But we have nearly 1 million messages coming in, and we can track everything about our solution coming in through the cloud services, into the IoT hub, through streaming analytics, and back into our event hubs in real time. And so anytime you build an application like this, even with streaming analytics, you want to track its progress and alert and notify. This is your operational view. So why did we choose Azure? Azure allowed us to concentrate on the business process and not focus on infrastructure. Its scalability and reliability is unprecedented. We could use partitioning with streaming analytics, and we could also increase the number of streaming analytics when a storm hits, and we have external crew that's going to send in a lot of messages, or devices or trucks on the road 24 hours a day. Developer productivity. SQL at its core is what Azure Streaming Analytics is built with. And Microsoft is one of our core technologies in Southern Company. We are mostly a Microsoft shop. So from a developer productivity, streaming analytics saved us a lot of work, a lot of extra data stores, and it was quick to put together with SQL. And then finally, one of the things that streaming analytics became the linchpin for is, as this data flowed in from these devices, you know, like I said, you're getting different types of data flowing in. So our current scenario that we just described was dots on a map. You know, where is this asset or vehicle? And so the streaming job really concentrated on, I want to show the active and inactive devices and provide it back to our back office systems who couldn't handle the amount of data that's really coming into the cloud. But another scenario, if we wanted to build another scenario, think about promoting safe driver. We could look at the acceleration, so we'd create another streaming analytics job and another event source that could look at the acceleration of the vehicle and the deceleration and the speed messages or alerts, and feed that into our lone worker or our safety driving program, our fleet management. We could also look at diagnostic messages and look at the distance travel or any alerts and feed those in to another system, our fleet management system. So streaming analytics allowed us to open up possibilities off the same data set. So all these sensors feed in. We can broker it from various vendors, so we're vendor agnostic and device agnostic. And we can get insights into it. And we can add new insights as we learn more about what the sensors are capable of sending. And so future plans, this right now is it's for distribution in Georgia Power. We're made up of several companies, and this is more or less a framework that is a brokered service for receiving IoT or other device information in the cloud and doing analytics and promoting a destination sync for those analytics to come back on premise. So it's a hybrid cloud solution framework that we intend to grow for these use cases and others.
Thank you very much.
Thank you.
And seriously, thank you very much, Greg. This really helps put perspective on like how customers such as yourselves can use some of the services that we are building on Azure. Thank you. All right, guys. So I hope you're inspired by this on what is the transformation that you can do to your industry with some of the real-time analytics that we are talking about. What I'm going to talk about now is talk about some of the new functionalities that we are adding and how we are continuously evolving the service which comes up. You know, I don't know if any of you guys went to think Sam and Satya and all of these guys also said, the evolution of how analytics and other things are happening is you have things which are happening on the cloud. Then you have analytics, you have IoT that actually picked up and started bringing more data into the system. Then you have edge analytics which is happening. And then now that you have all of this data and different targets of analytics, you can also put AI on top of it. One of the things that I wanted to talk about today is something that we are releasing today more in larger preview, which is anomaly detection, which is built into Stream Analytics. What is anomaly detection? We talked about some of the thresholds. Temperature is greater than 50 degrees or less than 10 degrees. I want an alert to come. But what if you want a machine learning model to automatically learn from the pattern of data so you can get an alert in case there is an anomalous situation from that pattern? And what if you want to do all this with a simple SQL function? That is fundamentally what we are trying to provide you as a customer. And we will give you more AI functions, text analytics and things like this in the future, but we are starting with anomaly detection because this is used in a lot of use cases. Let me actually tell you one other important part about this model. This model learns from the window that you have provided. So I'll show you a demo, and then I will actually come back to this slide. So if you remember the previous demo where I was actually just sending some data into the system, right? So I'm sending data into an IoT hub at 57 degrees with a plus minus 10 degree variation. The reason I'm trying to show all the demos in Power BI is so that you can visualize what is the impact, but you could actually send the results of this to any of the other syncs that I had talked about. So in this demo, I am going to go back to my Power BI dashboard. So this is the dashboard that I had shown you earlier, but I have a different dashboard which is called an anomaly detection dashboard. So what is happening in this particular dashboard is I am just showing literally in the top part the data which is being sent from here. So you're seeing between 45 and 47 and 67, correct? Now what I'm going to do is I am going to increase this, 484 plus minus 10, I could make it anything else. And I'm going to update the query. I apologize, there is a little bit of latency of the data being sent from here because it's on wireless and stuff like that. But what I did is I'm literally going and saying change the temperature from 45 to 484. Let's say a fire has come somewhere and your temperature is increasing. What you will notice is the temperature here increased and it became 484 and the new normal is becoming 484. But this below thing, which is the anomaly score, you see that increasing as well. So as the temperature is going up and the temperature changed from 47 to 484, you see this anomaly score going up as well. Now before I go and show you something else, I want this to continue for around 30 seconds. Why I'm saying 30 seconds is I've created a model in which it is actually learning from the last 30 seconds of data. You see after 30 seconds this anomaly score just dropped down. Why it dropped down is because the new normal now is in this 400 degrees. So how did I create this? So let me explain what I've done again. I'm just sending some data. I increase the temperature through a spike. I am looking at what is the history of the last 30 seconds in this case, and it's configurable to a day, like whatever you want based on your use case. And then I'm seeing is there a variation from that in the result that I'm getting. And I'll also tell you I'll do this in like less than 10 lines of code. So I go back to the dashboard and I am going to open the job in which this is actually being done. Oops, that's not the right one. This is the right job. So this job, as if you remember, is still reading data from that same IoT hub. it is sending the data to this Power BI dashboard, which I just showed you on the screen, and there's an alerting thing which I'll show you in a second as well. But let's look at the query. So let me control one it so you can see it much better. So what is happening in this query, and I won't go into all the details, but I'll just hit on the top parts. If you want more details, I can talk to you later. We added a new function in Stream Analytics called anomaly detection. We worked with our machine learning friends, took their anomaly detection online learning model, embedded the code of that model fundamentally into Stream Analytics. So now instead of thinking ML, you can think in this function, anomaly detection, I care about temperature. I want to actually score each temperature reading which is coming, and I want to score this over the 30-second window. So every 30 seconds, I want this model to recompute itself. I can do this in one day. I can do it in a longer time. I get multiple results. One of the results that I'm showing in this demo is a bi-level change. So bi-level change basically has values based on the degree of anomaly which is detected. This is where you saw the second line which is going up and down. And that is it. I literally have to do just this one thing rather than setting thresholds, rather than understanding, to know when an anomaly has been created in my system. Now, the second part of the demo is basically when the bi-level change is greater than 4, and we have documentation which explains what all of this is, then I want to get an email, and I will talk about this when I do the Azure Functions part of the talk. But I hope you understand what I mean by that, how we have taken the complexity of machine learning and online learning model. Like I could have changed this to 5 minutes or 1 hour, and still the same thing would have worked in a very interesting way and brought it literally down to a SQL-like language. Okay, I'm going back to the deck right now, and you can use this with partitioning, you can use this with a variety of other things. If you want more details, it's all there in the documentation. We can talk after this session. The other thing that we introduced recently is triggering Azure Function. So you saw all the outputs which come from Stream Analytics. One of the outputs is Azure Functions. Folks have heard about Azure Functions? I can actually take any arbitrary, I think Python code. I can put my code into Azure Functions. I can call HTTP endpoints. One of the scenarios that we did this for is customers coming and telling us, you know what, I have some custom applications that I have built, like line of business applications for monitoring my system. In case an anomaly occurs, I want to be able to call that custom application. And Azure Functions does a very easy way to do HTTP callouts. So let me show you how that works through that same demo. So you see what I have done here is when the bi-level change score is greater than 4, I call a second output. That second output is alert. So let me go and see what alert is. I can have multiple inputs and multiple outputs and multiple logic in my one Stream Analytics job. The alert is basically an Azure function, and this is exactly how I am defining what is that Azure function. That's it. Everything is by configurations. Let us go and see what is there in the Azure Functions code. So what I want to do is I want to get an email whenever I hit an anomaly score of greater than 4. So this is how easy it is to now work with other Azure services like Azure Functions to do it. I basically go and say, this is my Azure function. I want to integrate with something which provides email very easily called a SendGrid message service. And here I can put things such as what is the email address that I want to send the email to, what is the from address, what is the message that I want to send it. I can manage this very easily. I can even monitor this. So if you remember, the score just went up to, oops, this is loading, but the score just went up to over 4 when I did the demo. So 6 minutes back, an email would have been sent. So you can, I apologize, you might not be able to see the screen, but that SendGrid function was called 6 minutes back. Let me show you this again. I can basically go and say, let me decrease the thing, let me click on update, make sure our anomaly detection model actually works. So now the new normal is between 400 and 475. Suddenly the temperature is dropping. Let us hope that the anomaly score is greater than 4. It's a machine learning model. We always don't know what is happening internally, else we would have set thresholds. And in this case, it is going greater than 4. So what would have happened is the second part of the query, which says if it is greater than 4, called Azure functions, would have got kicked off. And this function would have been called. And let me see how fast this refreshes. A few seconds ago, another email got sent. Let me see if the Hotmail email does come here. Where did I write the email to? Mail. Yep. So this is still in my Pacific Standard Time. You just saw an email just came. So you're seeing how I'm able to compose an end-to-end system with machine learning and calling services like Azure functions, which call external services to send an email very easily. Hope this gives you an idea of the new things that we have done with AD and Azure functions as well. I'm going to go back to the slides. Any questions here before I proceed? Yes, sir?
What type of impact on your bandwidth of your network is there if you're trying to stream all of these sensors at the same time?
That's a great question. The question is, what type of an impact do you have in the bandwidth of your network if you're trying to stream all sensor data? It really depends on multiple things. One, what kind of network you're using, how many data points that you're sending, what are the critical data points you're sending, and things like this. We have customers who say that we cannot really send all our data points. We have a customer who is working with us who has data coming from vibration devices which creates 5,000 readings per second. And they have multiple of these devices. And they're saying, hey, we can't really send it. So this is where we introduce this. Everything that I'm talking about stream processing in the cloud, I can actually run this on devices with Azure IoT Edge. I can write my same SQL query and I can send it to devices. I'm going to hold this here because later in the presentation I'm going to show you that as well. So, but hope that gives you an idea about what I'm saying. All right, so I showed you the real-time analytics and demo. One of the things that we have done is, apart from the SQL-like language, we started with JavaScript, and you can write any arbitrary code in JavaScript and call it as a user-defined function. If you're familiar with SQL, SQL has this concept of user-defined functions, which you can embed in your stream processing logic in stream analytics. What we changed it to, and today we'll actually very soon we will release this in public preview, is the ability for customers not just to score every single point. So I can use a JavaScript function on every point. But I can now start writing aggregate functions on a time window of data. So how I can actually write a stateful function. This is what we have recently introduced with JavaScript. Why this is important is now I can do my computations, custom code computation, things which we are not giving you in the SQL-like language, on a window of events. So these are things that we just added. For example, volume of weighted average price. Weighted average price could be some logic that you want to write in JavaScript, but then I want to do it over a window. So how we can enable you to do it using our JavaScript UDA is the new thing. We allow you to do things such as accumulate these. This is a little more complex, but you can see we want to go more and more towards the simplicity as well as people who have their own customized needs as well. Visual Studio tooling, and I hope I'm able to get back to my Visual Studio. But I've shown you a lot of things except the geospatial functions through the portal. But a very important thing is investing in tooling for developers. And so we have done things with our Visual Studio tooling where you can integrate with Git, you have version control, IntelliSense, which is built in. I literally can take my laptop on my flight, and assuming I'm not connected to Google internet or whatever it is, and I can actually write my whole stream processing logic, have some sample data in JSON or CSV, and test the whole thing out directly from Visual Studio without being connected. This is something that we did through our Visual Studio tooling. And once I get my logic correct, I can deploy it to the cloud. And I can monitor all my things also from Visual Studio. So if you are a developer, if you want to be in the Visual Studio, you can actually do ASA from there. I am going to try to go back and see if I'm able to as you guys saw earlier, for some reason I'm having some Visual Studio challenges, and I don't know what exactly that is. But if I'm not able to show this, I will, let me just close the program. It is basically saying there's some problem with OneNote, not sure why. But I hope you get an idea about what you can, everything that I did in the cloud, now you can do it in a disconnected fashion with Visual Studio as well and deploy it. Apart from that, we actually did something completely new as well. Okay, finally my Visual Studio is working. I apologize, Greg. This is the query that you actually wanted to show, which was an interesting query. Do you mind if we hold it till the end? You're walking through the query, but I think it'll be interesting. Because I actually want to show also the ability to do certain things. I can actually have my own project. I can set up what are my inputs and what are my outputs. I can run this project locally. I can do a lot of these things which can be actually done, like literally we have taken a runtime and embedded it in the Visual Studio tooling. So, and I can show you the results of like what is the sample data that I'm pushing into the system. I wasn't connected for any of these things. Why this is important is I want to go to that next stage of what we actually released recently. So what we did is, think about it from two different aspects. I'm a developer who is writing code, I'm checking in code, I'm doing certain things. But I want to be isolated from the people who are doing fundamental source control for your whole Azure deployment, right? You just don't want any developer to make a change and check in the change which gets deployed and breaks everything. You want certain unit tests and things to run. So what we have done is now I can integrate with my not just Visual Studio but my VSTS Online, and now I can actually do builds automatically. So I can use my Git, for example. I can make any changes, I can deploy the changes, add it, and once I do that, like if I use my Git and I can do some of those things, I can then go to Visual Studio and I can say get my new Git package, build my solution, deploy my solution. I need to put everything with regard to the resources only once, and the whole integration and deployment can be now managed offline. So this is something new which we have done, which is continuous integration, continuous deployment, which is going to also go out actually today. Other things that we are working on, we have monitoring, which is actually built into the system. I will try to show you a demo on monitoring, which I think is very interesting. So in the monitoring demo, one of the things that we have done, I'm going to go to the job in which I was doing some geospatial analytics, and I will pull something called a job diagram to show you an example of what kind of monitoring can be done. So in my job diagram which pulls up, if you remember, I had an input which was sending, car and weather information. I was sending car information to one event hub, weather information to another event hub. I had 5 jobs and I had 5 outputs. I can actually monitor all of this directly from the portal. I can see my car input is going to which exact jobs, how much data is coming from those jobs in the last time period, how much data is being processed in one of those jobs, and what exactly is that query, what is that logical pathway. So if I am seeing an issue in my output, I can track that logical pathway to see which exact query am I having issues with. So I can look at the metrics. This is actually, if you think about it, all I told you is you have a SQL statement, right, which was st distance or st within or something in this example. But how do I track the end-to-end to see I'm not getting an output? How can I go back by looking at exactly what is the metrics which is coming? What are the joins which are happening? So these are ways that we are actually helping in debuggability. We are also integrated completely with Azure monitoring, so you can set alerts, you can integrate with things such as, you can get issues such as in case my processing fails in a particular place, I want to know which exact event has that processing failed. So you can actually tap into your diagnostics logs to see it. You can do things such as define your own storage account because it's your customer. You are the customer. We don't want to hold your events. It's security. You only need to know that in case there's an issue with an event, you are the only people who have access to it. You can actually set this up through configuration for debugging and monitoring as well. It integrates with log analytics, which is one of the tooling which is available through Microsoft as well. Why I'm telling you about this is because I think when you think about PaaS services, the more you invest in debuggability and troubleshooting, the better it is for you. This is an area that we will never get perfect. I mean, I run the product team and I'm telling you this. Despite everything that we are doing, we will continuously keep on investing in this. We just invested in something which will enable you to get alerts in case there are issues which happen, whether you have lesser events coming in, processing is slow, and things like that. I just showed you the job diagram with metrics. This is a mission critical service that we have built. We have 3 nines of SLA. We do automatic checkpointing and things which I had talked about earlier. We have guaranteed event delivery. If you have sent an event to Event Hub or IoT Hub or Blob, we will process it. Even if, this is the reality of computers, right? My Visual Studio for some reason got stuck with one node. Processes do get mingled if something wrong happens, and systems do go down. But we will automatically recover from this. We will read your checkpoint. We will go back in history and read the data and ensure that always your event is being processed. What we don't do currently, and I want to be open about that too, we don't do what is called exactly once processing of events. So if we go back in history, you might see duplicates of results in your output. So things like this are important for streaming, and you have to ask these questions for your application. Customers who want exactly once have been actually implementing this at the source for us. Another thing, actually this slide is wrong. Right now we are available in 21 regions in Azure, completely geo-distributed. We are in Asia, South America, multiple in Europe, US of course, and we're also in sovereign regions. Sovereign regions we call are regions where we ourselves are not allowed to service the service. We have to do it through somebody else. The data is not allowed to go in or out. Things like regions like Germany, regions like China. So we are even in those regions. We have all the major compliance. As I had said, one of our first customers was in the healthcare. So we have HIPAA compliance, we have SOC compliance, ISO compliance. This is important when you're actually setting up an enterprise system. You have to think about these things as well. The last thing which I wanted to talk about, going from the cloud to the edge, and the reason I'm going to hurry a little bit is because I have 8 minutes, and I personally am excited about this, wrote the first paper on this some time back, is everything that I've talked about in the cloud. Imagine scenarios where you're disconnected from the cloud. I'm in an oil rig, or really, I'm running some application on my mobile device, which is important. I need to do some real-time analytics on that application, and I'm in a place where I have no network. But I want to keep on getting alerts in case something happens. I just made the application. Really, this comes down to a lot of key manufacturing scenarios. Right? I want to be able to stop a production line in case there is an issue. I cannot rely, I will lose millions of dollars in case an issue happens. I cannot always rely on my connectivity. This is the scenario that you were talking about. What we have done is we have worked with the Azure IoT team on something which they call the Azure IoT Edge in order to deploy these stream analytics jobs, which are writing in the exact same SQL language to edge devices. So I will try to see if I can show you a quick demo of that. But first I want to walk through all the use cases that this thing is useful for. Low latency command and control. We have a customer we are working with who is doing multiple percentages of savings because they are reducing waste from their factory. Why they are able to reduce waste from the factory is because if you really look at a production line is actually built out of multiple different sensors that you buy from different places. KUKA, ABB, different robotic systems and things. Each of these systems have their own SCADA systems. They don't talk to each other. I just showed you earlier in stream analytics how I can get multiple streams to talk together with a simple join, SQL join function, correct? Now, imagine what I'm doing in the cloud, I can do it on devices. So I can do things such as sensor fusion now on devices. I can do things such as intermittent connectivity that we talked about, or how do I reduce the data in that 5000. So all the aggregations, how I can just do in devices before I send it to the cloud. I believe, Greg, you had mentioned that even this is something that you guys might be interested in, correct, in this? What I will do is, I think I have 5 minutes, so I'm going to actually try to add an additional demo in this session. Wish me luck, first of all. So what I'm doing for this demo is, I have a couple of jobs, and I'm going to actually open up the slide of my previous session because I can actually show the demo the example of the demo much better from my previous session. One of the jobs that I have is a job which runs in the cloud. So this is the slide that I'm going to walk through. Again, I'm going to use my laptop as an event generator, but also a gateway device which has Azure IoT Edge running on it. I am going to send the data, the telemetry data from the devices, so all the sensor readings, to the IoT hub, which will go through a cloud job, which is JS_PPR Power BI, which just writes it to a Power BI dashboard. But I'm also going to open up an edge job. This edge job is going to be called ASA Edge PPR. And all this does is uses the IoT hub to communicate back to my device. So the fundamental processing is actually going to be happening on my laptop and not the cloud. So let's see if this works. All right, so this is basically the gateway, and I have started the gateway. I am going to go to my Azure dashboard, and I am going to start my edge job. And all I'm doing in my edge job, first of all, let me show you the input and the output. It is not any of the IoT hub or the event hub services. It literally is what is the serialization format that you're reading data in from the device through Azure IoT Edge, and what is the serialization format that I'm writing data in from the device. Then the other thing is, what is the fundamental device that I want to write the data to? And this is basically what I have in my machine running, which I call through IoT hub my first device. And then let's look at the query. Initially, I just want all the temperature and humidity readings. So I'm going to start this job. Oops, I clicked the wrong button. See, this is an extra demo, so I get some leeway here. All right, so I started this job, and what is really happening is, so I have another, this job is sending data to IoT hub, and then it's coming to a Power BI dashboard through my cloud job. And all this job is doing on the edge is it is sending the temperature and humidity. Okay. Now, and you're seeing this right here, right? It's just showing it on the dashboard. Now imagine if I want to say, I don't want every data point. I just want, let's say every 10 seconds, I want the data point to come, average temperature and humidity. I click on stop, so it actually goes and stops the job which is there running on the device. I wait for it to get into stop mode, and once it does, I can go to the query. I am going to comment out the first part of the query, and I'm going to enable the second part of the query. And this is every 10 seconds, I want the average temperature and humidity. I don't want to send everything else. See, this demo is specifically for your question, sir. And now, let me start, and let me see what happens to my BI dashboard. So again, what I'm doing is I'm pushing this down to the device. Let's see what happens on the device. Let me see if the job is started. The job has started. You saw readings were coming every 10 seconds. Oops, this is the wrong one. Now, the reading should only come every 10 seconds. I should not get a data point every second as I was getting before. So here it is saying my stream analytics job, it is working with the IoT hub in the twin state, and it is sending an output. So you see, now that same output which was coming is now coming only every 10 seconds. You're not seeing every second of that output. This job is not running in the cloud. How we made this work is we worked with the Azure IoT team. Azure IoT team is basically having something called the Azure IoT Edge. The Azure IoT Edge allows you to deploy containers of other services like Azure Machine Learning, Stream Analytics, Azure Functions, and we literally take this job, create a container out of it, and deploy it on the edge device. The edge device can be a server, it can be any device greater than 128 megs of RAM, it can be Windows, Linux, multi-platform, and things like that too. So I hope this gives you an idea. One thing I do want to say, this is something which is in very early private preview. If you are interested in this, please let me know and I can get your team signed up. This experience that I showed is going to change completely. We are working with the Azure IoT team on a new experience where the customer can say what are all the different containers they want to deploy to a multitude of devices, but you get the idea of what you can do with Stream Analytics, not just in the cloud, but also on the edge. So with that, I want to actually finish with one last thing which I always like to say in my sessions. When we think of streaming data, everything that I have talked to you about is time series analytics in real time. One of the new services that we released recently is Azure Time Series Insights. This allows you to do your time series analytics not only over real time, but also historic data. OP Ravi, I think he is there. He's in the audience. He is going to give a session tomorrow. This is literally how do you do time series analytics over historic as well as real-time data. Very interesting. It kind of augments. It helps you do root cause analysis and things of different behaviors, anomaly detection over real-time and historic data and things like that. There's a lot of resources that you can go into. I'll take questions. I know I am actually over time in 2 minutes. I hope, just to summarize, you guys got an idea about why is real-time analytics important? What is streaming analytics? What we are doing with Edge, with the cloud, how customers like Southern Company is using us to fundamentally help define new scenarios. And I hope you got some motivation from this session and ideas about what you can do. Thank you very much. And thank you, Greg. This was very helpful. Okay. Any questions, guys? Yes, please. People who want to stay for questions, please do stay. Yes.
Where is the data storage?
The question is, where is the data storage thing? Are you talking about time series insights?
Yeah, basically when the data is coming to the IoT
Hub,
hub
yeah.
and to the stream.
Yeah.
Like for example, if in AWS it actually can be routed to S3 or something, but in this case where the actual data is getting.
This is a great question. So the question is, in AWS, for example, if I use Kinesis streams, I can write it to S3. Where it is being stored here? Actually, it is very similar to what you can, it's a little more than what you can do in AWS. We can write the data from a stream analytics job to a blob store or SQL Server database or Azure Data Lake or Cosmos DB.
No,
So
how does they do the queries, right?
the queries is actually, no, so this is what is streaming analytics. The query is happening in memory. The query happens even before the first write is executed.
Oh, okay.
So, hope that explains.
So it's not stored anymore.
No, it's happening in memory. Yeah. Any other questions? Yes. Oh, for the edge, can I? Let me just write it on the screen. So you will. So please email. nrtpmteam@microsoft.com. This is my team's alias. If you have anything, any?
Key differentiators between stream analytics versus Spark streaming.
Yep.
Some of the open source.
The thing is, sorry, I'm repeating this so other people can also know. You're most welcome. The key differentiators really come into the developer productivity that we have talked about, the multi-tenant service that we have talked about. There is no cluster management. You don't have to do about any of those things. We actually have built our service on Trill, which is fundamentally a stream processing engine. If you look at Spark Streaming or Spark, it is an interactive engine on which they have built batch and streaming. So you have to create your RDDs and things. Here, you don't even have to define what is the size of your RDDs and stuff like that. We automatically actually infer from the data whether the batch size is too big or too small. So we actually automatically, if you want to call it RDDs, you can call it. But we do that micro batching internally. So we can also do things for smaller sets of data and larger sets of data. Now, things we don't have, which Spark Streaming has. Currently, because we provide a multi-tenant service for security, isolation, we only allow you to run JavaScript code. We don't allow you to run R and Python and Java. This is something we know and we should be working on. I think that's a good way to put it. And this is where, right, imagine you have to set up a Spark Streaming cluster. Like literally the cheapest stream analytics job with everything that I showed you, $71 a month that you'll have to pay for it. So that's another way of thinking. And yes, sir.
As far as all these devices, there's always a question of data integrity, data quality. Are there templates that come out of this for like, hey, this device is all fine, the sensors?
Actually, this is the first time I've been asked this question. This is something that if you send an email to this alias NRTPM team, I'll be honest, I'm not the right person to answer this. The right person to answer this is Sam George, who runs the Azure IoT effort, because it really is, whether you use streaming or not, there's compliance, there's security and compliance, and I know his team is working on this, so he'll be able to give you a better answer. Thank you.
What about MQTT transactions?
MQTT brokers. So right now our ingest sources are Event Hub and IoT Hub for real time. But when you look at edge devices, Azure IoT Edge is running. You can use MQTT brokers to work with Azure IoT Edge in order to do it. But this is something which is keeping on coming up a lot more. What we do not do right now is we do not allow you to take your own custom inputs and custom outputs. The reason is because it goes back to the Spark Streaming question, right? The flexibility is there, but now you have to manage everything. You cannot give the guarantees of SLA. You cannot give the guarantees of exactly one, or at least once delivery of events and things like that, which we want it to be a fundamental of the PaaS service. So these are.
So one last question. What is the use case of Suleika.com? I just saw in the list. Do you remember?
I do not. But what you can do is, it is actually there. If you go to Microsoft customer evidence site, or if you send me an email on this alias, I'll find that out. You're welcome. Yes, sir.
I think I missed, where does the transformation happen? So if you've
It's
got
in
data
memory.
in a certain format,
Yeah.
it needs to get into a common format or something that,
It happens in memory, actually. All of stream processing is in memory,
in which component?
in the job component. So I write my data to an Event Hub or IoT Hub or in the blob. Then what Stream Analytics does is it actually pulls data automatically with a millisecond latency. And in the Stream Analytics, like you are giving what is called a streaming unit, which is the compute that you're giving to your job. That is where we are actually running the processing.
So if it's in a different format, that's where you would do the transform, so
Yeah.
it becomes a
So there is another important point, and actually, to be honest, I should have said this earlier, and I forgot to mention this. Thank you for reminding me. Currently, we support JSON, CSV, Avro, gzip formats. We do not support the custom binary formats currently. We have heard this feedback. We know we got to give custom code in order to enable people to have other formats, so you can do the processing within the job. Customers who are bringing custom binary format right now use something like Azure Functions just to do the transformation and then push the results to an Event Hub, and then Stream Analytics can take that JSON or something. But we have heard the feedback. The challenges in giving custom code, we truly built a multi-tenant service. That's why we are not asking you to buy a cluster. It would have been so much easier if we said, go buy a cluster and let's manage it. We don't have to care about security boundaries and things. Right now with a multi-tenant service, we have to ensure that the code that you're writing does not access memory allocation, which is with somebody else's code, right? I mean, the security boundaries. So we have to work with Azure in order to enable that kind of resource isolation. Sorry, I'm going into the next level of detail, but you can kind of see why it's SQL. And the reason we can do JavaScript is basically we have the Chakra engine. So Chakra engine is an isolated component which can run basically within your process. Hope that I gave you an answer and I told you why we can't do it. But the fact that I told you why we can't do it with these details might lead you to how much we might be researching this topic.